And we are live. Hello, everybody, once again. My name is Sanket Shikhar, and I welcome you all into today's session, where we will go ahead and talk about GPT and beyond. Well, if you haven't heard the word GPT, probably you are living under the rock, but GPT has changed the way how we work, how we go ahead and take care of our business. And today we will go ahead and deep dive and understand what GPT actually is, how it works. And we'll also go ahead and talk about the rise of language models in NLP and conversational AI. In order to go ahead and talk more about it and take you into this beautiful universe, I have with me Darren Lefko. Darren is joining us today from London, England. And just to give you a small brief overview about him, Darren comes from a physics background. Well, he holds a master's degree in physics from Imperial College of Science, Technology and Medicine, London, where he started his career as a satellite engineer. Following satellite engineering, Darren since has been involved also with the credit markets. He has built credit derivative trading platform for trading desks that ran for over a decade. Now, currently, Darren is also involved with machine learning, artificial intelligence, and big data for the purpose of trading, decision-making, which he has a huge passion for, where he solves business needs. In addition to it, he is also from the top 1% in the Stack Overflow and well-versed with languages like Python, Visual Basic, JavaScript, Node.js, C++, and Fortran. He has also published multiple books, and that's just about the tip of the iceberg when we go ahead and talk about Darren. So without further ado, let me go ahead and pass on the mic to him so that he can go ahead and get this webinar kickstarted. Darren, the mic is all yours.
Right, thank you. And this time I've started my timer and I've left it for 45 minutes. So there's 15 minutes for questions and answers at the end, because usually I've historically overrun. So hopefully I won't need interference towards the end of this. But this is quite an interesting topic. And when I was asked about this one a couple of days ago, I was like, okay, it's going to be easy. And then I kind of like went into everything, and this is probably one of the biggest fields around. It's just absolutely humongous. And there's so many directions that this talk could have taken. But basically, I'm going to stick with the title, which is GPT and Beyond. And it's the rise of large language models in NLP, which stands for natural language processing, and conversational AI, which is artificial intelligence. And so we'll go through everything. I think there's about 45 or 50 slides. Let's have a little 44 slides to go through. Some of them will take a few seconds and other ones will be a bit longer. And I've actually also got some links to other pages that I will jump to, but I won't spend too long on, just because we are kind of like limited for time. So again, who am I? I'm Darren Lefko. Yes, correct, as was introduced already, master's degree in physics at Imperial College. And I started a career doing satellite engineering and then moved into finance and spent the best part of 25 years there. And I'm actually probably returning there as well shortly. So aside from that, my contact details are here. So you've got LinkedIn, which I did click on the testing thing. So my LinkedIn profile's there. You're welcome to connect. Feel free to connect. My email as well, if you want to, and Twitter, which is now, I believe they become x.com, had to modify the slide. Is it x.com now? So my Twitter handle's there too. And a couple of publications really, but one or two things before we begin, which is a book on Python programming. And if you are looking at this space, and if you're interested in this space, really the core parts of it, or a huge amount of it, is done in Python. There are other languages as well where core modules are built, like C++ and so forth, but really for data science, AI, the ChatGPT, and we're actually going to see some of these models. Quite a large portion of it is in Python programming, and that's sort of like why it's shot up in the scales in the last few years. It's just become quite popular for that. And as a side note, an interesting book on trading which is called Stand Behind Me, and it's the full life cycle of a quantitative trader, which is quite interesting. Nothing to do with this subject. It's not very mathematical. It's more about the life cycle of someone in an industry like this. So it makes for a very, very good read. And just moving on finally, which is really the sponsor of this talk, Exaltius, so thanks for sponsoring the talk or introducing me or asking me to give this talk. And I just thought I'd read out their mission statement quickly, which I've extracted from the website, which is our vision is to establish ourselves as a premier provider of technology solutions and training in Asia, recognized for our unwavering commitment to customer satisfaction and excellent product quality. So it sounds like a good enough statement. But yeah, thanks for inviting me to talk. And with that, I think it's time to start, and we'll just go straight into the introduction. And interestingly, of all of the topics that I was given, I thought ChatGPT or GPT and Beyond, I thought I'll go and pull out one. I'll use one of the many, at least one of the 4 or 5 language models that I tend to use, which is Claude AI, to generate the entire presentation. But it didn't quite work out like that. But although it did help with about 50% of it. So I thought I'd kind of like do that because it was interesting to let the AI guide me rather than me prompt the AI, which is the normal way around that we do it. So about 50% of the slides are created by well, they're created by not ChatGPT but Claude AI, which is one of the many rival competitors that are popping up, and I might even mention those at the end in the Q&As if we get asked about it. So the introduction is defining large language models and how they work and explaining how they work, and then a brief introduction to GPT. GPT stands for Generative Pre-trained Transformer. It's quite a mouthful. So what does kind of like all of that mean? It was created by OpenAI in 2018. We'll touch upon that as well. And then explaining how GPT started a revolution in NLP, which is natural language processing, by showing the power of large pre-trained language models. So just moving on. The first question really is, what are language models anyway in the first instance? And a couple of bullet points which show this, which is that they're trained on large data sets of text-like books and websites. And when I say, I've highlighted some keywords here, which is large data sets, we're no longer talking about thousands of rows on an Excel sheet or even like millions of rows in a database, but we're now touching upon tens of millions, billions, and multiple billions of data that is passed into these various models. So they're really growing quite large. And the next part is learning statistical relationships between words, and that's kind of like the key component of a lot of this, which is the English language, or in fact any language now, because these things are available in like 70 different languages. So multiple languages are broken down into their statistical relationships, and that's what is used for these transformer type models. So given some text, we want to predict the most likely word, and that's what these models are all attempting to do in some way. And if we were to cast our mind back maybe like 10 years ago, you could pick your phone up now. If you were typing, it would do some sort of predictive text, but it wouldn't be predicting an entire sentence, but it might be doing your word completion. So if we typed in hell on our mobile phone, it might complete the word to hello. So, or if we type in he, it might give us some options like hell and hello and other things that are likely to happen. That's word prediction, but the GPT models are going far beyond this. So they're also looking to generate text by iteratively predicting the next words. That's what they do. And they do this in a couple of different ways. One is looking at the near part of the sentence, and the other one is looking at the entire context. And again, when we look at the different types of model that are around, we'll see that. And finally, pre-training enables strong performance on NLP tasks, natural language processing tasks. So I'm just going to jump straight in really to the statistical relationships between words. And I think this image, which I took off the internet, but I put the little orange squares around it. Words are predictable. And if we look, and I might highlight it and then just do an undo of the highlights if I can. Let me see if I can get the pen here. Draw, there we go. Can I draw on this? Try to draw. Well, this little component over here, I meant to draw a squiggly line. Let me hit undo. There we go. This little area over here, it says rugby. I don't know if you can read it or not, but it says Rugby World Cup Springbok skipper, and then the name of the skipper carries the title weight of the Rainbow Nation on his shoulders. We notice Rainbow Nations in quotation marks as the first black captain of the South African rugby union team. And this then, so we get all of these words. These are our combinations of words, and then they're broken down. I'll do a couple of times, get rid of that. They're broken down into their sections, and what we see is some words repeat themselves. So there's a little bit of a cleaning process. The cleaning process has here removed some capitalizations and stuff, and it's removed the quotes from around the Rainbow Nation. So we clean up our words, that's the process of it, and then we do something whereby we make a dictionary, and it's a word number dictionary. And if any of you are familiar with computing, it's something like a key value pair where the key is the word and the number is like a number that's allocated to the word. But then when we see some repeated words, they don't need the number to come up again. So the has come up 4 times, and I think there's other words in there like as, I think, or of has come up a couple of times. So that they only have one representation in the dictionary. And then after we've created the words, this dictionary of words and their numbers that are associated with them, we can actually also just do things like extracting out the good words. So sort of like removing all of the ands and thers and buts and so on that don't really form the English part of the sentence. So that's generally an overview of kind of like what's happening. And a lot of what we're going to do is looking into overviews. We're not going to go too far into the details, although I might throw some examples out. Or I do throw some examples out. So one of the things that we have, and there's a couple of modules that are available, but well, there's many modules that are available. Python has like thousands of them, and quite a few are for the natural language processing type of operations. But one of the popular ones is this natural language toolkit. It's known as NLTK. It's a leading platform for building Python programs to work with human language. And it provides easy to use interfaces to over 50 corporate and lexical resources. And I could click on a link here if it does work. I'll click on a little link, just kind of like, just for a little guidance overview so you guys can see what it is. And I've extracted a tiny piece of the data out of this. So it's more a case of having a look yourself. But one of the things that I might draw attention to is the contributions. I think what here there's over, this began in 2000. So this is an old project that's been continuing, and it's got like many contributors. You can contribute to it. And also just a quick scroll down and why we can't like go into depth in this talk. Like just one model alone is humongous. This is just one module in one language. So it's quite large and complete. So we move on, and I'm just going to do like a little brief of one of these modules. So the natural language toolkit is an interesting one, and I have touched upon it and used it. So I thought I'll do this one. And this is only what's about 10 or 15 lines of code. But what it actually does is what we import this module, this natural language toolkit. We can use this in Python very conveniently. And then we can pass in a sentence, which is this component over here. So maybe if I again get to the drawing little piece of it, we can pass in a little sentence over here. Which says, hi, my name is Darren. I'm doing the lecture, and some parts are easy and other parts we have struggled on. And then we can do processes on the actual document itself. And one of the things that we can do is we can do this word tokenize, which basically breaks a sentence down into a bunch of words, and these words are the tokens. They get somehow converted mathematically. So we're taking our natural language and we're mathematically going to try to convert them. So we first do our tokenization, which is getting these tokens. And then the next procedure after that is the tagging process, where we apply tags. So each word gets allocated something. And we can see like these symbols here, these are the tags, and they're referring to like nouns and verbs, and a name, it comes up as NNP. So just things like that in general. I'll get clear and move on. So that's generally what they are. And I think somewhere actually put a breakdown of what those little pieces were as well. So the toolkit does this effectively, which is it does something called parsing a tree. So we can display a parsed tree with the natural language toolkit. We pass in this sentence that goes in, and it then starts breaking the components down into all of the bits. Now, this is an example that was taken off of the web, but here we have the sentence at the bottom, which is the green word, which is Pierre Vinken, 61 years old, will join the board as a non-executive director November 29th. And we can see that all of these words, like the names are like Pierre and Vinken, they're identified as names, they're given NNP. And if I was to zoom in, but this is very tiny on the side, like take it from me, the NNP, it says here proper noun, singular. So the names have been recognized. And then there's something like NNS, which is noun, which is plural. So the language is being broken down in some sense. We can see that the numbering here, 61, which is an age, has been broken down into CD. So in some sense, these all of these types of processes are initially at least trying to do that, which is break our sentences down and tokenize them, and then pass them into dictionaries of some kind for more processes to be done on them. Now we briefly come in to introduce GPT. We said what GPT stands for, this generative pre-trained transformer. It was created by OpenAI in 2018, and I do have some links anyway late that do point onto that. I think it was the first popular model that came out. I've got it on the desktop personally myself, although I do tend to use other ones now because I'm trying other ones out. It's a large company that's at the forefront of all of the pre-trained transformers, and it was trained on 8 million web pages, so a large amount, but that's only the original version, the 2018 vintage. So there's latter ones, which again we'll review because we're going to see the progress as to what's happened in the last 5 years effectively. And then finally, it shows potential, or at least what it did do, GPT, is it showed potential of pre-trained language models. That's kind of like what it really did do. It made a breakthrough. So what is a generative pre-trained transformer? I kind of like put up this picture, and we'll go through some of the slides and they will describe them in a bit more detail. But how a generative pre-trained transformer looks is generally this image, and it has some text, and it does some extraction, and it goes through a transformation process, and it produces some kind of outcomes. That's generally the pictures that we get for this type of stuff. And I won't go into the details yet, although on other slides I will do. And where did this all come about from? And really, it's all come about from this one document, which is called Attention is All You Need. And it's really interesting because the people that actually created this document, which I'm going to click on and we'll go to in a second, it was done by 8 Google employees, or several Google employees, I'm not sure how many. But I'm not sure that they were aware of how revolutionary it would be. So they kind of like just published this innocuous document, which we're heading over to now. It's only a 10-pager. It's definitely worth a read through. And it talks, I won't go into the reading of it, I don't think, but you'll see some of these images crop up. But they talk about attention, scaled dot product. Then there's a function here, this soft max function. It's a, we'll have a look at that function as well. So I kind of won't talk about it yet. We're going to get to it, but it's some type of AI decision-making function, and so forth. So this document is well worth the read. I'll keep this tab open, although I don't think I'll come back to it. And on the side, basically, is the actual kind of like model of the original transformer. So this thing that was here, and what happens is we've got this this input embedding that comes out, and the output probabilities. We're going to see the mathematics of it, the very top level of the mathematics of it. But this soft max output probabilities is what we're going to see. So just some terms, just to debunk some stuff and just show the very top level of maths again. Softmax is this mathematical function that converts a vector of numbers into a vector of probabilities. And it looks like this exponential function divided by the sum of an exponential function. And it looks effectively like this, which is very close actually to a sigmoid function. And we get all of these types of functions that occur that have similar sort of levels. And what actually happens is a decision needs to be made, and we've got a left hand side which is like a no, and a right hand side, the right hand side of the model. So effectively, if I draw the two sides, we have this side of the model which evaluates to a no, and if I change the color, we have this hand side of the model over here which evaluates to a yes. These things feed into the neural networks, they get much bigger than that. So that's generally what they are. These functions feed into the hidden layers, and so there's multiple layers in what are actually deep neural networks. So a standard neural network is like 1 or 2 layers, but now we have deep neural networks that have emerged as a means to tackle the complex problems such as image classification and speech recognition. And these deep neural networks have more than 1 or 2 layers in there. So we've got a hidden layer 0 here, layer 1 and layer 2. So there's 3 layers in this network, and these decisions are made, and then they're kind of like remade and then remade, and we get some sort of output from them, which is representative of that sigmoid function. Finally, we want to come out with a conclusive decision. And in our natural language processing thing, is sort of like, what is the next word or the next few words that are going to come out. So we're also going to look at, we've kind of like briefly touched upon it, but how GPT started a revolution in natural language processing. And we look at its impact on natural language processing. And the first large pre-trained language model, and it had 117 million parameters. We'll see the context of that later on when we get into some of the slides. State of the art on many NLP, natural language data sets in 2018. This was the birth of everything. It showed the benefits of pre-training on large unlabeled data. So that's kind of like, the key thing. That was like the breakthrough effectively, and demonstrated the power of scaling up model size and data. And finally, it's inspired follow-up models like GPT-2, GPT-3, which is kind of like the current usable version, although there's GPT-4 and Megatron, and other things beyond that as well. So the follow-up models to GPT is, we had GPT-2, which came out 1 year later in 2019. It was a bigger model, and there was better text generation. And then hot off the heels of that, we had GPT-3, which was 175 billion parameters of human-like text. And then models, this is an evolving process. Megatron Turing, another model, trained this time with 538 billion words. And then the Jurassic model, again, we see these very large numbers that are popping up, billions of parameters, billions of words, and so forth. And finally, Palm 2022, so just a year ago, 540 billion parameters, state of the art. And I've put some links to some of these, again, just to kind of like have a quick one-eye glance at them, should we say. So this is Megatron Turing Natural Language Generation. This is done by NVIDIA, and I'll only read like the first sentence of each one of these, but Megatron Turing Natural Language Generation is the largest and most powerful monolithic transformer English language model with 530 billion parameters. And they talk about the number of layers and so on and so forth. So I'll close that one down because I'll just jump through all of these very quickly, but it's really just an awareness of what's out there. So the next one is the AI Studio. And again, I think maybe the best way of looking at this possibly is some are built for developers. This one's in the Python language again, and I wonder if there's other bits. I won't delve into it too long just because of time constraints. But let's just click on Palm very quickly as well. This is Google's version of it, which is the Pathways language model. And again, scaling to 540 billion parameters through performance. And again, you know, it's worth taking a look through the website and all of the data because I'll never be able to cover it in time. So again, just moving on. I made this little chart myself. There's a much better chart on, I think it's slide number 42 or something, but the number of charts, the number of parameters has increased meaningfully, and we can see here that GPT doesn't even register. It looks like a 0 on the scale of kind of like Megatron, Turing, and Palm, and so forth. So just to understand where we kind of like are in the context of all of this stuff. So then we move on. We're going to look at the benefits of pre-training and exposure. It provides exposure to a huge range of real-world text, and the word huge is highlighted because it really does. We're talking about billions of parameters, so very, very large, or hundreds now, hundreds of billions of parameters, very large stuff. It learns representations for useful downstream tasks. It reduces the need for labeled data. So this is what the pre-training does. If we can reduce the need for labeled data on each task, then we can gain some efficiencies. And it enables transfer learning to new tasks and improves sample efficiency and generalization. So that's generally the benefits of the pre-trained training. So we look at the rise of GPT. We're going to explain the GPT architecture a little bit and the training process. We're going to discuss benchmarks that show GPT's strong performance on many natural language processing tasks, and mention some key innovations like the transformer architecture and pre-training on large data sets, and finally explain how GPT shows the potential for scaling up large language models. So the GPT architecture and training process is basically what we have is a transformer encoder architecture. There are 12 stacked transformer blocks, and if I was to jump back, it was to slide 14 with this, or slide 14 and slide 13 with the original images. Those are the transformer blocks, and we can kind of effectively stack them, you know, to gain more, to enhance the architecture. And they're trained to predict the next word in sentences. That's effectively what they're doing. And they're trained on this book corpus data set, which is 800 million words. Again, there's a little link to it here. I like to go to this one just to read. Again, the first line of it, I could have put it into a slide, but it's better that we see where it is here. The book corpus, I'll actually zoom in so everyone can actually read this. The book corpus is a large collection of free novel books written by unpublished authors, which contains 11,000 or more than 11,000 books, around 74 million sentences, 1 gig of words, and 16 different subgenres. So, just think about the number of books that you might have read in your entire lifetime. It might be 1,000, maybe even 2,000 or 3,000. These types of data sets are just humongous, just in terms of number of books, let alone number of sentences or number of words. So when we're talking about big data, this book corpus really kind of like again highlights it. And this is the basis for a lot of the training. I won't go into the rest of the benchmark stuff. And then it's fine-tuned on supervised tasks. So the benchmarks that showed GPT's strong performance is, and here's some of them. It outperformed prior models on pen tree rank, and I'm going to go into. I'll jump into each one of those briefly as well. So let's just have a look here, and we've kind of like seen this bit here, but English pen tree bank corpus is a particular and in particular section of the corpus corresponding to the Wall Street Journal. It's one of the most well-known corpus. It means corpus means a set of data. And again, we can see that it contains a huge number of sentences and, just under what 1 million tokens. So again, just a large data set that's there, and the training can be done against these types of things, and we can measure our performance on these types of things. And then state of the art on race and Lambda data sets. So here's a link to Lambda. There's a little popular image. Maybe this is the Hugging Face. So the popular Hugging Face website. And again, I can't like just implore you to go through it, but I'm just wondering if I can find from here. The Lambda data set is extracted from book corpus and consists of 10,000 passages and so forth. Again, we're talking about large data, and it comprises of 203 million words. So, and we can measure all types of performance measures and things are done on these data sets. So the next one is it had strong results on something that's called COCWA, which is let's just click on it actually, because there we go, it's going to say it, which is conversational. CO stands for conversational question and answering challenge. So basically, it says here anyway, it's a large scale data set, or another large scale data set for building conversational question and answering systems. And the goal of it is to measure the ability of machines to understand text passages, so things that we put into it, and answer a series of interconnected questions in a conversation. So attempting to be Turing-like. And again, this set of data contains more than 127,000 questions with answers collected from 8,000 conversations. So big data again. And it performs well on sentiment analysis too. I'm going to jump out. I won't even click on that link. Maybe we'll come back to it. But these are the kind of like the benchmarks, and we want to see how well we perform on each of those benchmarks. So just to go through the slides so that I can keep up with the time, we're going to talk about beyond ChatGPT. So there's ChatGPT 2, GPT-3, Jurassic. We're going to explain how models get bigger, over 100 billion parameters now, discuss the improvements. So there's certain things like sparse attention and something called mixture of experts. I've got a couple of high-level pictures for those. And mention multimodal models like DALL-E that incorporate vision. So this multimodal thing, I'm going to go on a whole slide on it. It's looking not just at chat, but at other things that we can do in the AI space that are related to GPT in the same way. So the first thing to talk about is advances beyond scale. Sparse attention reduces computation for self-attention. Again, there's a little link here. This is the first, I think. I wanted to like click on this quickly. This is the actual OpenAI website, generative modeling with sparse transformers. And they've got a little bit of documentation on there. But one thing that was actually quite nice is they put their code, they make it public, and you can actually go onto the attention model in Python. I'm literally just going to scroll down. It's only 250 lines of code, and some of those are just print statements. So it's just interesting to see what's there. Everyone's telling you, you know, what they've done and, you know, how good their thing is, but they've developed a sparse transformer, which is basically instead of a dense set of numbers, it's sparse numbers, and it extracts patterns 30 times quicker than previously possible. So just new mathematical techniques that come into play. Mixture of experts, which divides a model into subcomponents, and then you can sort of like collect them together so you can do other things. Tokenization, which we saw examples of in the coding, which more efficient text encoding. Quantization, which lowers the precision of parameters, so we can do things like smoothing and effectively, which makes our processing a bit faster. And then efficient scaling methods, so a modern parallelism. This is a very common thing in computing, and pipeline parallelism. So basically to combine computational power and sort of increase the speed of the models. So mixture of experts, again, just very, very high level, because we've only got 10 minutes roughly before the Q&A, but we can get multiple expert networks. They're called learners, which are used to divide a problem space into homogeneous regions. So regions that kind of like look similar, and then kind of like pair them together afterwards. So some form of top level parallel processing. The next thing is tokenization, and this is something that I made. Again, it's another module, so not the natural language toolkit one, but a different one called Spacey. I'll just click on it here so that you can have a little look at what Spacey is. Where is that actual? I wonder if I can pull it out here. So like their key line as to what it does. Help you do real work. It's quite a front end thing in Python, and it goes straight to kind of like help you do real stuff straight away in your code. And one thing that I do, all I have to do is import Spacey. This is only like half a dozen lines of code. I put in something like, my name is Bar and I'm 16 years old and I have 2 sisters. And again, it does something. We can see it's created 16 tokens. It's used the full stop is 1 token. There are other things that we can do in Python and in other languages to split our sentences, but these modules are humongous in themselves. I won't click on it and go through it because we've only got 10 minutes, but they're absolutely ginormous, and they've been worked on by a lot of people, and they provide a humongous amount of capability. So we're able to basically do this tokenization process. And the Spacey module, just the overview of the structure of kind of like what it looks like, and you can find this image in the actual on the actual website and in the documentation. But basically, the central data structures in Spacey are, and it's this blue section here, which is this language class, or a class of things to do with languages. Then the vocab section, which is this little green section over here, and the document object. So it's kind of like breaking the mathematics into, or the computation into certain parts, and running its process through that. So moving on, again, we've got tokenization. The mathematics of this is actually relatively simple, and I've done a little example of it. I've taken the this string, and I've done an NLP, so this language processing thing on our string. And if you're familiar with doc strings in Python, which is just basically for loops, I'm able to extract, you know, on the first bit, which is, I'll draw quick lines on this if I can. Can I get the line thing going? Yeah, over there. So this one here is pointing to the index over here. I wonder if I can get the lines, maybe I'll do it this way. So that's the index, and all it's doing is counting out a bunch of numbers, like the items that they are. The next one down is actually breaking down the text into the words. And if we notice things like 16 here is a word on its own, or is a token on its own. The full stop is a token on its own. So they're given a position because they mean something in the language. And then we can see if we can do various things on our tokens. So we can see if the word is alpha means, is it a string? So is it actually a word? So this is a word, this is a word, this is a word. So it does that. Then it's also looking out for is punctuation. So this full stop somewhere will apply to something like this true over here, because that's a piece of punctuation. And here is like number. And if I maybe color it in a different color because I'm running out, but this 16 over here would have fed into this like number, and it would have been the true over here. So we can literally, or the models can literally break the language down into their component parts and identify all of the different sections. And these are things, again, that feed into our language models. So if I hit clear, no, I'm doing loads of times. That will probably do it. Okay. So undo a couple more times. There we go. So just moving on, because we've only got 5 minutes and there's probably about 10 slides. Quantization, which is a common compression operation to reduce the memory footprint of a model and improve inference and performance. And it's kind of like breaking things down and making everything a little bit smoother. It's just the purpose of improving performance, basically, with a smoothing type of process. Let's move on to some more practical things, and we're going to go into the semantic discussions, but applications of large language models. So we're going to summarize some key applications like text generation, translation, question answering, then give examples. So some examples are chatbots, chat engines, and creative writing. You may have used some of them. I've certainly used, I've done some creative writing, and I do a lot of coding actually with them as well. So I could have thrown that in. Discuss how models can be fine-tuned for specific tasks, and now I think even that's referred to as prompt engineering, so it's got its own term. And mention risks needed for ethics in the application, so we'll talk about that. So the multi-modals are like DALL-E. So what are these multimodal models? So DALL-E generates images from text. I'll do a quick click on it. This is an OpenAI version, and from the image we can get out that it's a car. It tells us here, okay, this one is actually a plane, but it says it's a car. Like, can we guess what the right thing is? So, and here we've got an astronaut riding a horse, so we can input some text, and it will create an image back out. So we've got that. We can generate images from text. Likewise, clip, we can match images to appropriate text. Again, an OpenAI thing. And here we can see, like, you know, various images. I think I found one that was actually quite useful somewhere down below, but sort of like this. And even as a human, like, I don't really know what this is, but it says it's a photo of guacamole, which is a type of food. So it's kind of like, some cases, these are actually better than humans now. Then there's blip bidirectional linkage between image and between images and text. So again, I try and click on that quickly. This one here, I just wanted to go in just to show a lot of this you'll recognize, apart from the markdown, it's Python stuff. So here's a pre-train on the model and so forth. And we can see that some of these things aren't actually even that long in lines of code. Python does a lot of simplification. But a lot of the hidden hard work that is here is done in the module. So if you learn these modules, like what a lot of these modules are, like PyTorch, it gives you a huge amount of power, like hugely powerful. And then fusing language, audio, and visual models. That's what FLAN actually stands for as well. Again, part of the Hugging Face thing. And it's got here things like instructional fine-tuning. Please answer the following question. What is the boiling point of nitrogen? And, you know, it's sort of like a chain of thought one. So a chain of thought is answer the following questions by reasoning step by step. So if I was to ask, you know, the class, the cafeteria had 23 apples. If they used 20 for lunch and bought 6 more, how many apples do they have left? You know, can a model do that kind of thing? And in, again, some cases now they're beginning to do them better than we as humans can do them. So now in the last couple of minutes, get through 10 slides quickly. We're looking at the future. So speculate on the future capabilities of models as they continue to scale. We're going to discuss some challenges. I'll leave that for the Q&A maybe. But things like bias, safety and alignment. Bias is like if we put a whole bunch of very, very biased data in, our GPT models will come out with some very biased data out. And then we should mention a few frontiers like reasoning, common sense, which one of the slides will cover it, and multitask learning. Finally, let's go on to speculating the future capability. So in the future, we're looking for more human-like conversational abilities. So kind of like focus on the highlighted words, which is human-like, and then a greater depth of reasoning and knowledge. So again, focus on the depth of reasoning. That's really what we want. Human-like depth of reasoning, understanding and generating multimedia content, and increased ability to learn. And that's, again, a highlighted thing, ability to learn rather than just pre-processing transformers. So that's what we look forward to in the future. And strong performance on complex real-world problems. Again, we're looking for complex real-world problems for our next steps forward. Challenges like bias, safety, and alignment bias. So models can perpetuate problematic biases in training data. So, for example, if you know, we've trained all our data on very, very racist information, we'll have a racist model, and so forth. So, like if we train all of our data on mathematical stuff, then it will just be good for maths, and it won't be good for other things. Then we look at safety. I've got a slide on that, so I'll go through it very quickly here, but the potential for harmful behavior and outputs. Alignment, which is ensuring that models behave according to our human values, but all of our values are different. So one person believes in that we'll have huge arguments about those types of things. Then there's the interpretability, which is understanding the model behavior and its decisions. And finally, which is probably aligned to alignment, is ethics, which is developing models responsibly and addressing the risks. So I go on to this slide very quickly because while we talk about all of this ethics and stuff, people can get carried away with how GPT and these language models and AI and machine learning will kill us. They absolutely won't. Just like the invention of fire, on the left-hand side, we can use these things that could be potentially dangerous for a whole bunch of very, very constructive things. Fire gives us energy, light, warmth, and cooking. But then on the flip side, it can burn your house down and it can kill you. So if when fire was first ever discovered or invented or however it came about, if everyone stopped it, we would lose all of the benefits of it. So we've got to be careful about suppressing our technologies. Then we go into the frontiers. And I'm just going to literally fly through the last few slides because I want to leave time for the Q&A. Reasoning abilities and symbolic manipulation. So, you know, we want that's where kind of like we want to make our breaches from. We want our new models to be able to reason and interpret stuff there symbolically. Integration of knowledge and common sense. So again, I highlight that at the moment we have integration of knowledge, but we don't have common sense. Learning new tasks from small data. Well, at the moment, we're learning from big data. So can we manifest that into learning from small data? Multitask and transfer learning capabilities. So again, highlighted really, but learning capabilities rather than just repeating stuff. And incorporating additional modalities like vision and robotics. So can we finally get all of these things like a vision and a text and an audio and combine them into like one singing, dancing human robot? So finally, just the conclusions part really, which is, so we're going to recap on the progression of GPT until now. We'll emphasize, although I've already kind of like done it, how the language models are transforming NLP and AI. and conclude that future gains will come from smarter models, not just the bigger models. So the progression since GPT, we kind of like looked at some of this, but models are scaled up 100 times in size. In fact, it's probably more than 100x in size. Massive growth in available training data. So that's been very, very fundamental for everything that's happened. Our collection of data, which is digital now, the growth of that, which has been tremendous. It's kind of like we're able now to put it into our machines. Advances like sparse attention and mixture of experts, which we kind of like covered early on, just the the top levels. Multimodal models, which incorporate vision and robotics. So again, things that we're looking for in the future. We have the pieces of them, but they're not like complete, and they're not good enough yet. But that's where the community is trying to get to. And more capable of conversing, reasoning creatively. But there's key challenges around ethics, bias, and safety, which I don't want to guide everyone to ask, but maybe that's kind of like hot on the list of things. I'm just going to go through these last few slides very quickly, or let you read some of them yourselves. But the transformative impact of language models on NLP and AI. So it talks about state of the art across most NLP tasks. Enabling new applications like conversational agents, so like chatbots, but again, something like a Turing version of a chatbot, so something that's better than what we're all currently used to. So like, and Turing means Turing completed, and we can't tell if it's a human or a bot anymore. So where it gets to that level. Foundational major advances in pre-training techniques, driving progress in multimodal learning, spoken about that. And I highlighted this one, demonstrating capabilities once thought outside of our reach. So we're doing things that you couldn't have imagined even 10 years ago, and certainly not 20 or 30 years ago. So we're touching things that are just on a different level, and ushering in a new age of large model foundation for AI. And again, like I did my own version of a chart, but it's always nice to find ones that kind of like highlight your own data. But here is the number of publications and citations, and like if we go back to 1990, so we're only going back like 30 years basically. So that's within lifetimes of many people that might even be watching like our little chat here. But there's an exponential growth in the community and what's happening. That's in the citations, and the same thing for the model sizes. So there's GPT over here, and this is put on a log scale, because like literally, if it was put on a linear scale like I did initially, GPT doesn't even register. So we've got 10 squared here, so 100, and then we've got 10 to the power of 6. So we've got thousands and millions. That's the model size, and then also the data size, which is orders of 10 to the 1 gigabytes, and then 1,000, 10 to the 3 gigabytes. And finally, just really pictures. I just wanted to throw this in because it actually shows. I think I took this out of the GPT website, but a lot of it's named after Sesame Street. So there's the Sesame Street characters, and it's funny that it's done like that because Sesame Street taught some of us when we were kids, or at least you'd watch it when you were kids, and you'd learn the ABC. And here we are, they're teaching us all of that. So maybe serendipitously that's why these language models have been given the names of Ernie and Bert and Grover and so forth. So, and finally, this is a picture just to have a look at, and not really to read the words of, but we can see the branching outs, and they're kind of like classified in different sections. Here's something about like vision, and here is something about speech. So all of the different colors have different sections. This is really kind of like branching out in all directions. And that brings me finally, for the first time ever, probably on a presentation, to a conclusion in a timely manner. So I will leave it, move on. I guess the hosts will take over or something, but thank you for listening. And time for some questions and answers. I've left several minutes. There we go.
Thank you, Darren, for this intriguing session. I was listening very carefully, got a lot of insights from your session today, and I'm sure that was the case with the other participants also. Darren, you can stop the screen sharing now. You want?
Okay, yeah, sure. I'm trying to figure out how to stop it.
I'll do that.
Stop share. There we go. Yeah, okay.
All right, so that's about it. That brings us to the end of today's session. Now, I've already shared a form with all of you guys. So if anybody of you wants to go ahead and upskill yourself, get familiar with all the technology, especially in the field of data science, cybersecurity, or anything else for that matter, you can go ahead and connect with us. The link is there in the chat also. I've also shared it on the screen so that you can fill it if you want to. Having said that, now let me go ahead and open the house for questions. So if anybody has any questions that you want to ask, anything that you want to know, talk about, you can go ahead and type it in the chat, and we will be more than happy to go ahead and take your question.
I can actually make, someone just asked in the chat, can we have a copy of the presentation? I can. It's done on Google Slides, so I can actually make it available, and that would actually give you guys access to the link, so you can go and click
Awesome.
on.
You can even paste the link over here also if you want in the chat itself.
Yeah, I can do it. I think I've got to do a share on it or something to be able to. I'll post it into a website or make a link in some way.
Awesome. So that takes care of the first question. Any other question, guys? Anybody has anything that they want to ask? There's one question that I see. Darren, this is interesting. There is a lot of debate online whether AI will replace people in the workforce. Some people argue that AI will lead to mass unemployment, while others argue that AI will create new jobs. What are the thoughts on this debate? Do you think AI will lead to mass employment? Before I go ahead and jump to you, Darren, let me go ahead and share a simple example that probably people who are in their 30s will at least relate to. We had a similar situation in the late 90s when computers were actually being introduced with Word. There's a lot of people who were believing that computers are going to do everything, so there won't be people that will be required anymore. That's not the case, isn't it? Now you find a lot of people sitting next to a computer working. So it's something similar that I believe, but let me go ahead and get Darren's view on it.
Well, you kind of like nearly answered my question, but you answered it in a way. But I'm going to go further than that, which is throughout all of time, and I'm going to go back further beyond any of our lifetimes. But if we look at the Industrial Revolution, which was a case where in the UK, and the UK kind of like led the world at that point in time, a lot of machinery came in to replace people, and everything was moved from the local houses into big corporations. And so along came the tractor, and the farmer thought he was going to lose his job, because the farmer used to walk behind the horse and cart plowing the field. So at first it looks like it's a risk to you and you're very scared, but actually what the farmer doesn't realize is he's going to be the person potentially driving the tractor. He's going to be able to harvest more crops. And then there's going to be somebody manufacturing wheels and the windscreen wipers and putting roofs on the tractor and GPS and AI. And all of a sudden we have this an amazing farm that feeds the whole world. So if we were ever scared of the introduction of these types of things, they're actually letting us move on and do more productive things as human beings. And as someone who does coding, and I see something like ChatGPT come along, the level of coding ability, and I actually did want to share it, but I didn't have that. But the level of coding ability that it's brought, it hasn't replaced me. It's just made me a 10 times better coder. So again, we're kind of like potentially scared of these things, but that's the same if you're a story writer or something else. You'll use it to enhance your work, and you're now just 10x more powerful than you were the day before. So and the other part of it anyway is, if you're not part of the revolution, you're going to be part of the Luddites that are killed by that revolution, because whether we use it or not, somebody else will. So be part of it.
That is very well explained. And yes, that's the to see, nothing takes your job, more or less. It's like just that upskilling is part of our lives. You have to go ahead and keep yourself upskilling. technology in 5 years is like 50 years in human life, as we already discussed. Things change, the way we used to work change. And HR in 1995, was more doing a lot of repetitive and desk job and stuff as such. But in HR in 2023, it's evolved. It's more strategic. It's more, data driven. So role responsibilities, they will keep on changing. It's your job to go ahead and make sure that, you work with it. Today, Python is very popular when it comes to data science. Who knows, 5 years down the lane, there's some new language that comes and, that becomes more popular. You have to upskill. Everybody has to do that, not necessarily for a specific domain or a specific job role. It's more or less for everybody. Sayam has a question: how can we determine which career path should proceed with, and what factors should we consider? This is a question that I get a lot. Sayam, to be honest with you, there will be people who will help you in order to choose your career path. But again, there is a lot of introspection that has to be involved with it. You have to decide what you actually like, where your interest lies, and perhaps that will go ahead and help you do that. If you want, and if you have already filled up the form, you can talk with our counselor. You can send me an email also. I would love to go ahead and have a conversation with you, understand your background, where you come from, and perhaps, what would suit you the best. But again, nobody's going to tell you what to do. We are going to help you figure out what you want to do. That's the approach that we have.
I might add one thing, which is because I've got 3 kids and they're 12, 14 and 16. And actually, one of the things, and we don't actually realize this, but if I look back even at my parents, they couldn't have envisaged the job that I was doing because the job never existed. And I keep trying to repeat the same thing to my kids. And that's something that you've got to consider is half of the jobs that are going to exist in the next 10 or 20 years, they don't even literally exist. And I could pull out something like a film star from 20 years ago. Everyone wanted to be a film star, maybe. And now everyone wants to be, I think it's called a social influencer. So it's just that. So you kind of really got to think, in many ways, we're potentially, we can guide only the first couple of steps, and then we're incapable of answering ourselves.
That is true. That is true. And that's how the universe functions. There's always going to be new things, evolution that will keep happening. Well, digital evolution is quite faster compared to human, but that's how the world is. So I guess, Sayam, that answers your question. If you want to go ahead and deep dive into it, I'll be open for a call. You can send me an email.
I might answer the next question, which is Alexa, Cortana, and Siri.
Sure.
I was going to type an answer out, but maybe they don't use identical algorithms, but all of these companies are using similar technologies. So they're competing and they're trying to they're doing variants and they're making different versions. They're trying to improve it. They're trying to improve techniques. So the core parts of them will be similar. They will inherit some of the mathematics. But yeah, they're not identical. So I think I'll tick that off as I guess that's answered.
Yeah, for those of you who don't know, the question was, do Alexa, Cortana,
sorry, I removed it myself.
Do Alexa, Cortana, Siri use the same algorithm? So all of them are trying to solve a problem statement which is similar. The approach is a little different. That's the gist of it. Melissa says, I'm in the field of education. Would AI increase the level of intelligence of student, or it's the other way around?
That's
Melissa,
a good question.
Yep, that's a good question. Let me tell you a few things that we actually go ahead and do in order to solve that problem. This is not the first time that I'm hearing this. We have been working on this also. See, education in 2023, it's not a one size fit all thing. Everybody has different approach. When somebody comes to us also to upskill, we make sure we understand where you're coming from. So there is obviously a lot of AI that is involved in order to go ahead and do it. So again, there are multiple ways in which you can do it. Let me get Darren's views on it also. He has also trained hundreds of students. So then what's your take on this?
Yeah, it's an interesting one because if I take the sat nav in my car, before sat navs came about and they were popular, I used to know every single road when I was driving. And when the sat nav came along, all of a sudden, I stopped knowing all of the roads around me. So on the one hand, you could argue that I knew a lot more before, and on the other hand, you could argue I used a lot less. So there's that two polar answers. I don't know if that question is like a loaded question in a way. But one thing that we can say is that you're certainly more powerful with the tools available. And if I could even say, like, if everyone wanted to put that, I don't know if you can put your hands up in this session, but if anyone even knows what a log table is in mathematics, you've probably not even heard of it. But that was something that our parents or grandparents might have used. And that got replaced with the calculator, simply because it's not needed. And the calculators now are replaced with mobile phones. They're just simply not needed again. So we are becoming reliant on these things, but at the same point in time, we're becoming powerful. And the amount of information, if we use it the right way, is we've got. I've probably said this in other lectures, but in this phone here, which is probably just a £100 or £200 phone that's 3 or 4 years old, there's more computing power in this than all of mission control that sent man to the moon. And there was, I think, 450,000 people. So there you go, all in one device.
That's very well said. You cannot run away from AI in the world that we live in today. You'll have to embrace it, and you'll have to make sure and understand how you can go ahead and get it better. There are recommendation systems. There are multiple things that we also suggest to students, in order to go ahead and get better at what they do. I hope that answers your question. More questions are there. We'll try to take as much as we can. Rafael says, there's a number of research opportunities for high schoolers using AI. Can you tell us more about some of the exciting opportunities available, and how can high schoolers get involved? Well, before I jump onto that, and with that, we have a similar internship opportunity that we offer at Exaltius also. If you go ahead and go to the Exaltius page, you'll find virtual internship option over there. We also go ahead and do that. So if anybody wants to go ahead and do a hands-on internship to understand how AI actually works, there's a 8-week internship that you can enroll into from our website also. Darren, what would you like to say? High school schoolers and AI.
Start with I've actually got a YouTube channel now, which I just go through and basically just start on the web. There's loads of companies, even the company that I'll be joining in a month's time. They've asked me to not code and just to be like the COO of a company, but like they want like all of these firms and things. They want graduates to come in. They want young people. They're not hiring old people to code. They're hiring the younger generation to learn. So I think really it's guiding yourselves along those paths and just reaching out to people.
What is the best way to train a machine learning model without using LLM? Abdullah Akmem is asking this question. Sorry if I didn't pronounce it correct.
Well, okay, the large language models are just one section of them. But when we talk about machine learning, it's broken into a whole bunch of different sections. So I'm not sure necessarily that there's something that's potentially a best way. There's just a multitude of different ways. So there's several types of things that you can do, depending on the level of complexity that you want to get to. But ultimately, a lot of these things are boiling down really to the neural network, which is a component that would be too difficult to solve analytically by humans ourselves. That is, if we were to build a model that tried to rival a neural network, we just wouldn't be able to achieve that. So really, it's every version with a neural network.
John has a question. He says, in research, please enlighten us on the security and legitimacy of outputs, because even proofreading softwares do use GPT-4 already. Will that be more advantageous? Thank you. Great and concise presentation, Darren.
Are you referring to I'm wondering if it is referring to possibly like plagiarism, for example?
Well, that's what I thought also when he mentioned proofreading software. So
because the first time I actually realized that ChatGPT existed was on Stack Overflow, and I'd managed to get myself into the top 1%. I was actually quite happy about that on Stack Overflow for answering questions. And then I went onto the website one day and it said anyone using GPT will be banned. And I was like, what is this GPT? It was the first time I'd seen it. And it's this language model. But what these, and there's something really interesting about this, which is what these language models tend to do is they're learning from a set of data that has pre-existed. So they're literally learning from the question and answer pools, for example, in the coding section of Stack Overflow and websites like that. And then they're answering on that. And if we answer in the wrong way as a community of people, because we don't always know the best answers, the model might pull out those biases, and it's evident for humans as to what those biases are. And you can tell sometimes when somebody's copied and pasted an answer back in to get a rating. So yeah, and it's again, it goes both ways. It's kind of like something that you need to be honest with yourself about, really, like how you use it, because ultimately, if you're just relying on the GPT models to kind of like do everything for you, and again, I've seen like many questions on that where someone's gone like, I've just gone to GPT and asked it to do this, and it was relatively complicated and it couldn't answer it, and now I can't do anything. They've now lost their own ability to reason. So it helps to an extent, and also it helps to the extent where the experts at using these types of large language models, and this is a new field in itself, and when I was talking about things that didn't exist, it's called prompt engineering. And really, to be able to get a good output from these models, you actually have to know how to ask the question or series of questions in the correct way so that you can help the model build an answer. So yeah, that's kind of like where we are.
Speaking of prompt engineering, we are also planning to go ahead and do a workshop on prompt engineering. So keep following us. We will go ahead and update you about the dates and times so that you get to know more about it also. Manish Kumar Day, he says, I'm not sure if I missed it, but do we know when ChatGPT is connecting to the internet to provide real-time current response?
It actually doesn't. So the GPT model, the original one, was trained on all data. I think it was up to, I think GPT-3 was trained up to all data up to 2021. So new information that's come about wouldn't be in those models, but some of the newer models are now using real-time current data. But that's again, you get advantages of the pre-training, but then you get disadvantages, which is that when new information comes in, they don't actually collect that. So nevertheless, it's still a tremendous amount of information. So
yeah, that is true. There are third-party APIs also that are helping. For example, Bing AI powered by GPT helps you connect, somewhat with the internet. So there are alternates that are available, but I don't know. We are not the correct person to answer whether ChatGPT is planning to connect with the real.
Well, I believe the one that I'm trying out now, which is called Claude AI, I believe that's their claim, although I've not looked at, which is basically their claim is that it's now using some current data. But the training word of this GPT is really the key part of it, which is you're feeding a lot of stuff in, and there's a cost to training. So if you want to get real-time data in there, there's a perpetual cost because you have to keep on effectively paying to retrain. So, and you'd have to be doing that in real time. So I'm not sure how that's achieved. But again, that's something that people will want to get, because you don't want a legacy model.
Awesome. I think we are done then. If there's any more question, guys, you can let me know. I'll wait for 5 seconds and then we'll go ahead. Okay, I see one. Bon has something to say. Is there a free GPT API that we can integrate to GPT in our system?
There is, but it's only free for 3 months. And I used it initially and I ran out of my trial. So they charge you for token usage. The NLP one is free. That's completely free, and the spacey ones, so the two that I had in the presentation, they're free. I've tried other ones out on my YouTube channel, and some of them you can, and then some of them they charge you after a certain point in time. So I did see one channel of how to build your own GPT on your own. And then it's completely free, but you wouldn't be able to train it to the same level as the other trained ones.
All right, so I guess we have time for one last question. We have already run over time. I'll take the last one that Patrick has. Patrick, well, it's a statement and a question. Patrick says, I don't believe AI will replace jobs, but I'm also confused about which jobs will be boosted. Okay, I heard that cybersecurity will be more important than before because generative AI is giving away vulnerable codes, and data science will also increase because AI's existence. Web development has become a lot easier because AI has proven great help. My question is, which of these career paths is best to pursue now that generative AI has become bigger and bigger? So software development, cybersecurity, data science, which is the best career path to take? Well, I don't know how to answer that question. Let me pass it on to Dan.
I don't think there is an answer. I'm not sure. I'm not sure there's an answer to that.
That's why I passed
but
it on
also,
to you.
I guess at the same point in time, has it which jobs will be boosted and which won't? Like this is going to ebb and flow in both directions. It's going to assist and then detract for the next decade, if not more. In both directions.
That is true. And with metaverse, augmented reality, virtual reality, Web 3.0, blockchain, everything coming into the picture, all three are actually going to go ahead and rise. Now, having said that, it's again, as I said before also, it's not about which is better, it's about which one do you want to get into. What's your niche? Cybersecurity is probably the only job that I can think of that boosts 0% unemployment. Data science jobs, they are going to go ahead and increase at least 3 to 4 times more in the coming 3 to 5 years. And well, software development, it's evergreen. It's never going to go ahead and die. It's never going to go ahead and be left out. So whichever universe you want to go ahead and pack your bags and move towards, you have to make sure that your interest lies in that zone, because we are talking about 3 different segments with 3 different kind of work. So Patrick, whatever your heart desires, you can go ahead and take that path. If you want some expert advice, you can always go ahead and call us. You can go ahead and send me an email also. Let me go ahead and type my email for that matter so that you have it. Just typed it in the chat also. Just 1 minute. So if anybody has any question, feel free to go ahead and get in touch. Either I can go ahead and have a word with you or I can reply. We'll try to make sure that we answer all your questions. But again, there are other parameters also, as in what your past is, which background you come from, what is your strong suit, and perhaps we can suggest you something that would be better. Latest programming AI can't be used outside resource, like from user expect large data set. Well, it's more of a statement, so I'll skip. I guess we are done with all the questions then. Thank you, everybody, for being a part of this session. I really enjoyed the conversation. I really enjoyed answering all your questions also. I'm pretty sure Darren had a good time also. And we would like to go ahead and bid our farewell for today's session. We are looking forward to seeing all of you into our programs. I hope all of you have filled in the form. If you haven't, please do. Please let us be a part of your upskilling journey and let us go ahead and help you become the best version of what you want to become. Any last words, Darren, that you would like to add before we end?
Only other than, well, first, thanks for inviting me to give the talk. Really to stay in touch for everyone, whether they stay in touch through you or in touch directly, because there's lots of companies as well, even while they're working, so even while they're studying with you, that potentially you can come along and work for a company or gain some work experience. There's plenty of companies that could use the assistance, and you gain work experience, and the company gains some kind of a freemium of some sort of like free help that they couldn't do. So it's a win-win for everyone. So really just stay in touch, connect on LinkedIn, and like I'm sure you guys have got a bunch of good courses. I know that I took courses in the other place, and they're really good. They're a great starting point. That's what kicks off the career. You're climbing a big mountain. You're starting at the bottom, and if you don't take the steps, you'll never get to the top. So if you die halfway, it's better to die halfway than to never make the first step.
That is true. That is absolutely true. Perhaps the hardest part is taking the first step. After that, things start to become a lot more easier. And we try to go ahead and train in such a way that anybody, coming from any background can actually go ahead and grow. So
everyone wants you to succeed, like whatever you do. Like everyone's always backing you to succeed. It's not in anyone's interest for you to fail. So whether you do a course, with Exaltus, or whether you, come on board and work with a firm or something, people want you to do well.
All right, awesome. So we are going to go ahead and take a leave now. Thank you, all of you. Thank you for being a part of this session. I am pretty sure you enjoyed it. I'm looking forward to seeing all of you into our programs. And on that note, this is me, Sanket, signing off. Thank you, Darren. Thank you once again for the session. You have a wonderful day ahead. And thank you, all of you. You have a wonderful day ahead too. Bye-bye. Take care and stay safe.